Hey, in this video, I'll show you how to work with a Scolopendra rig. Scolopendra is a rather specific creature to animate, so many legs and segments would be almost impossible to animate by hand. That's why this rig is designed for parametric animation. It allows you to specify the path and the surface on which the centipede should crawl, and the movements will be generated automatically. You can control the speed and other parameters of the movement. Parametric animation is created using the C-motion object, and the rig allows you to fix issues with the C-motion object's default behavior in situations when the character moves on complex surfaces. The rig has a simple and clear structure. The main parameters for setting up the movement are conveniently grouped in one place. Also, deformation joints are placed in a separate hierarchy for convenient baking and animation export to real-time engines. The model includes the following animation. Also in the scene, the materials and lighting for the redshift render are set up and give such result. Now I will demonstrate what the animation creation process looks like with a couple of examples. I'll start with a simple case, when a centipede crawls on a more or less flat surface. I prepared a plane with a displace deformer to add some imperfections and such spline path. The main parameters for controlling animation are located in the user data of the parent object of the model, Scolopendra rig. At the top are checkboxes for controlling the display of rig elements, axis controller, common controllers and joints, which are duplicated in the viewport. Then the parameters to set up the main movement. There are few of them. It can be toggled on and off. It is possible to change the type. Is static. The character will move in place, the line will move forward, and the path will move along the spline. In the spline path field, you need to specify a spline. I will drag a flower here. In theory, there can be several splines here and they all will be combined into one, but I recommend using one spline object to avoid problems. In the surface field, you need to specify the surface. It can be any polygonal object, parametric object, or generator. I'll drag the plane here. If I press play, you can see that the Scolopendra is crawling along the spline, taking into account the surface bumps. Sometimes you need to go to the first frame several times in order for the motion to update correctly. Also keep in mind that for best results, the spline should be close to the surface. The step time parameter specifies the length of the step cycle in frames. This controls the speed of the animation. If the cycle time is reduced, the centipede will move faster and vice versa. It can be animated. Keep in mind that because of this feature, the animation cannot be scrolled, because it is calculated from frame to frame. Changing the speed in time looks more like working with simulations. To understand the speed of the centipede and its position in space, you need to play the animation from the first frame. Or do a preview. In the antenna motion group, antennae movements are configured. You can toggle it on and off, adjust the speed the same way as in main motion, and also enable antennae dynamics and even specify objects for collision calculation. Keep in mind that collision calculation works slowly and artifacts often occur. For finer adjustment of movements, you can edit C-motion objects, phases, amplitudes, curves, etc. C-motion main for basic movements, C-motion antennae for antennae. Now I will demonstrate a more complex example in which a centipede should crawl along such cylinder. Pay attention to this controller called axis control. It sets the direction of projection of rig controllers on the surface. The direction is from the top of the pyramid to the center of its base. The orientation of this controller can be animated so that the rig is projected correctly at the right time. Keep in mind the limitation. This projection direction is the same for all parts of the rig. Due to its length, there may be situations when it will not be possible to project all parts equally well. In order to export animation to real-time engines, you can bake all the movements to the transformations of deformation joints. To do this, you need to select Joints hierarchy and apply the Bake command in the timeline editor. Select the range, remove the Create Copy option, Set position and rotation, and click OK. Now you can export the geometry and joints to an FBX file.